How do we analyze data for a correlation? This is when you want to just see if two measures are related, two measured variables are related. Your null is that your population correlation is 0.00. Small, medium, and large are 0.1, 0.3, and 0.5. You're probably like, well, what does my correlation tell you? What does my R value tell you? Well, R value means correlation. When you square your R value or your correlation value, it tells you percentage overlap between your two variables. So when your percentage overlap is 100%, your two variables are the same. 0%, your two variables are completely unrelated. In between percentages are in between overlaps. So if we take that let's take that small value of 0.1. 0.1 times 0.1 is 0.01. Multiply that by 100 is 1%. 0.3 times 0.3, that's 0.3 squared, is 0.09. Multiply that by 100, that is 9%. 0.5 times 0.5 is 0.25. Multiplied by 100 is 25%. That's how you convert a correlation R value into a percentage overlap value. You just square it. Now, your data will look like this. In this case, we have 4 participants, and we have measures of anger and happiness. Are anger and happiness related? That's the question these researchers asked, and they asked 4 participants. So how would we analyze this data? First, we got to enter it in. So in Jamovi, it's always 1 row per participant. So participant A gave us 1 anger score and 1 happiness score. Same for all the other participants. Now, if you're looking at the variables themselves, this participant variable is an ID type. Your anger variable is continuous. And your happiness variable is continuous. You should be able to change these to ordinal and get the same results, but I'm not going to do that today. I know this works. This is what we're going to do. You click Analyses, Regression, Correlation Matrix. You can click them in one at a time, or you can select them both and click them in at the same time. I click Shift and they both go in at the same time. You can play around with that. Now, for my correlation coefficients, Pearson is the traditional R. I also want Kendall's tau B, which is a non-parametric correlation. I talked about that in class. I would like my correlation value. I would like my significance value. I would like my confidence intervals for my 95%. I would like my correlation matrix as well. So let's see what we got here. Our correlation value was 0.000. Our p-value was 1, right? Our 95% confidence interval is between a negative 0.961 correlation and a positive 0.961 correlation. Kendall's tau is 0. The p-value is 1 as well. This lack of correlation is not, like, we can see this here. What do we know? We're seeing no correlation. Our p-value is non-significant, so we didn't disprove the null. And our 95% confidence interval suggested this correlation could be anything between a negative massively large correlation and a positive massively large correlation. With this data, we know nothing. When I look at the scatter plot, I'm looking for lack of linearity. I have 4 data points. They don't look curvilinearly related, really to me, but maybe they are. You could kind of see maybe a U right there, but we would essentially need more data points. This is just a very small data set, but you always look at your correlation, see if you see something weird. This could be a curvilinear relationship, and we should probably measure 100 participants to test this result. But that is how you do this. I'm not going to explain what everything means. We have our p-value, our 95% confidence interval. Interpret those. We did not disprove the null, and our population correlation is somewhere between these two values most of the time.